Welcome to the second session of the Energy Storage module. Learning outcomes we aim at today are gain some insight in renewable energy and feedstock use in industry, look at renewable energy use and storage for transport applications, and learn about storage or demand response as an approach. Storage of energy or demand response, what to consider. Here we look to the energy use in a renewables-based society. Remember that is one of the factors that determine what the system needs in terms of storage in time and, as we will see, also the technical form of storage. If we look to all energy use in society, it is distributed over these sectors in the current mostly fossil energy-based system. 1/4 is industry, 1/4 is households, and 1/3 transport, for instance. But in a renewables-based future, all these energy uses will need to be based on renewable energy forms. How to make these energy uses renewable? Looking at industry, there's energy use and the use of energy containing feedstock for producing goods. For the future renewable energy-based system, we need to look at how these energy uses can be made renewable. What type of energy is then used and how is it made renewable? To get an impression, let's look at these highly energy-intensive sectors as example. That is iron and steel making, chemicals like ammonia and methanol production, and the production of minerals like cement for concrete. How can those industries work in a renewable energy-based future? Iron ore can be chemically reduced to iron by using hydrogen instead of coal. The iron oxide is then converted to iron. So it can be done using renewable energy, and industries are starting to develop that. It also needs high temperature heat, which can also come from hydrogen fuel or electric heating. Main thing to see, if one has hydrogen, this can be used for steel making. Ammonia, NH3, production can be converted to run on green hydrogen as well. The current fossil process uses hydrogen produced from steam methane reforming. The subsequent ammonia production happens on the right side, binding hydrogen to nitrogen in NH3 molecules. Using renewable power, however, one can produce green hydrogen by electrolysis and then do the ammonia synthesis with that and with nitrogen from air. So one sees it can be done with renewable energy. Another example is the carbon-containing chemicals production. For instance, plastics, fibers, or oils used in various products. They can be produced from a carbon-containing source and hydrogen. In a renewable future, this could be some biomass or recycled materials. However, these material sources are limited, and one therefore also needs to resort to carbon dioxide as a carbon source. And this graph illustrates how, starting from a carbon dioxide capturing source and hydrogen, one can synthesize carbon monoxide and hydrogen, and with the Fischer-Tropsch process, synthetic oils. These can then also be used for plastic making. Note that, again, one can perform all this with green hydrogen as input energy. A last example is cement or concrete making using renewable energy. This starts from the main raw material, chalk or calcium carbonate. With high temperature heat, one can convert that to calcium oxide, releasing carbon dioxide. The heat required can be provided using hydrogen as a fuel or electrically. This is also a chance to produce carbon dioxide, by the way, for the previous plastic making. The calcium oxide with water solidifies while curing concrete. Interesting to know is that the solid concrete absorbs carbon dioxide from our air during its lifetime. So what is a common factor for these example processes? Making them renewable can be done, by stored renewable hydrogen and electricity inputs. Clearly, also other ingredients are required, but these can also be collected if you have renewable energy. So that's iron oxide, nitrogen gas, calcium carbonate, carbon dioxide. Normally, steel and chemical plants operate continuously, so intermittent operation would be a challenge, or sufficient storage for continuous operation is needed. Another sector with energy use, transport. This used to be about 1/3 of energy use when using fossil energy. These types of transport are necessary. What kind of renewable energy would that need? That is under development, of course, but here are some suggestions. Light vehicles, battery electric or hydrogen fuel hybrids, trucks, hydrogen fuel and battery electric, trains, electric, airplanes, synthetic hydrocarbons, ships, ammonia as a fuel. These onboard storage of energy comes from with choices. Good to know is the following. The current fossil-powered transport is relatively inefficient when looking at the required kilowatt-hour of fuel per kilometer, and it emits carbon dioxide. Hydrogen is about 2 times more efficient, while battery electric is about 5 times more energy efficient. That is, if one has electricity directly available to put in the electric vehicle. If electric vehicles are charged by electricity coming from a hydrogen gas-fired power plant, however, the energy-efficient electric vehicle is as efficient as the hydrogen route. And this could be the case in winter when solar power is lacking, for instance. Another consideration that can influence the choice for batteries or fuels is the recharge rate. Here one sees what we are used to using fossil energy. A large travel range is loaded within minutes. One could realize similar loading rates with hydrogen fuels, as you can see. Electric charging of travel ranges is more challenging though. So this can be another consideration in the choice of energy for the transport sector as well. What kind of green fuel can one use? Well, compressed hydrogen, liquid hydrogen, methanol are often mentioned. But in shipping one may also use liquid ammonia, we will see later on. The transport sector still needs development, and different types of transport may use different forms of energy, electricity or fuel. Irrespective of the form of energy chosen, it has to be available in order to be usable. So storage must safeguard security of supply. So that's about making energy use renewable for now. Thank you.